Welcome to my channel Ganit Matrix. My mission is to help the engineering students to master the complex mathematics through clear step-by-step solutions. If you are preparing for engineering mathematics courses for universities like JNTUH, JNTUK, JNTUA and IIT JEE, you are in the right place. I specialize in breaking down the difficult exam problems into clear step-by-step solutions, so you can walk into your exams with total confidence. And this is area in Cartesian coordinates problem series, problem number 4. In the previous 3 problems links are given in the descriptions, so you can watch this and share these videos to your friends, and this will be helpful for your engineering mathematics exams. Now here, coming to the problem, find the area bounded by the ellipse x square by a square plus y square by b square equal to 1. So before going to draw the region, right, since our ellipse x square by a square plus y square by b square equal to 1, the region is symmetric about y axis. Why? Because if there is a point x comma y on ellipse, then the point minus x comma y is also on the ellipse. So why? Because if you replace x with minus x and y remains same, right? If you replace x with minus x whole square, that becomes x square by a square plus y square by b square equal to 1. The curve remains same. So therefore the region is symmetric about y axis. If the region is symmetric about y axis, that means the points are plotted on the first quadrant x comma y, second quadrant minus x comma y. So our region is located in first and second quadrants. Hence, to calculate the area, since the total area is calculated into as 2 times the area bounded by the ellipse in the first and second quadrants above the x-axis, because it is given above the x-axis. So what will you do? We will calculate the area of the region in the first quadrant and multiply it with 2 to get the total area. Hence, how to find the limits? Since the area formula is double integral over r dx dy or dy dx, since we draw the vertical strip AB in the first quadrant and identify where the strip enters the region and where the strip leaves the region. Since now taking the order of integration dy dx, so I am taking the vertical strip. Now dy, since first we are integrating with respect to y limits must be functions of x and x limits must be constants. So to find the limits, now we identify where the strip enters the region and where the strip leaves the region. It enters the region at y equal to 0 and leaves at, now we express y as a function of x. So y square by b square equal to 1 minus x square by a square, and y square equal to b square into 1 minus x square by a square. Now y equal to plus or minus root of over something, so that is b times square root of 1 minus x square by a square. So y varies from 0 to b times root of 1 minus x square by a square, and x varies from, so here 0 and the upper boundary for the first quadrant a. So x varies from 0 to a. You think horizontal, x varies from 0 to a. Plug in the limits. So integral dy is y. Now we substitute the upper limit, b times square root of 1 minus x square minus square root of 1 minus x square by a square. Now this is 2b by a, integral 0 to a. So this is square root of a square minus x square dx. Integral square root of a square minus x square dx is So this is the direct formula. X by 2 square root of a square minus x square plus a square by 2 sin inverse of x by a. Substituting the upper limit. Now if you substitute the lower limit, you substitute the upper limit, so x equal to a, so here we will get 0, and similarly here sin inverse of a square by 2 sin inverse of a by a sin inverse of 1. So a square by 2 sin inverse of 1 is remain, right? Now if you substitute the lower limit 0, x equal to 0 here we will get 0. Next here sin inverse of 0 by a sin inverse of 0, 0. So if you substitute the lower limit, we will finally get 0. For the upper limit only, so here we will get the second term a square by 2 sin inverse of 1. Since 1 is sin pi by 2, so this is a square by 2 into pi by 2. So this is 2b by a into a square by 2 into pi by 2. So this is, which is pi a by 2. Thank you.